Okay, now for the fun calc. Here we're going to do center of mass. That's not what I want. But now this is still going to be a single body, but it's going to be non-uniform. Still a thin rod though. So yay for that. Now, since it is non-uniform, that means our linear density, lambda, is no longer going to be m over L. Okay, because it's not uniform, so we can't just take all the mass and divide it by the length. So instead, this is going to be something like a baseball bat. So say we have a baseball bat, or a club, evidently, okay, going from 0 to L. It's a blob with non-uniform density. So now the linear density of this is going to equal something. It varies depending on the shape. But this is something that will be given. That's going to be given to you. You just have to use it. So for this one, we're going to say that our linear density is, let's say it's x squared over L squared. Now we still need to use lambda is still dm over dx, so we're still going to be subbing in this into our equation. The only difference is we can't sub in m over L. So, and there's also other things that are different, but we'll get there. So we still start with the same equation, but we have to break this into two parts. So before, our m canceled out when we plugged in m over L for lambda, but now it's not going to cancel out. So we're going to have to deal with 1 over m, but we'll do that later. So essentially, we deal with this and this separately. First, I'm going to show you how to do the integral of x dm. Now we're going to sub in lambda dx for dm. So we're still going to integrate from 0 to L to the other end. And we subbed in lambda dx because now we can integrate with respect to our position, but we need to sub in our lambda as well, just like before. And if in this case, lambda is x squared over L squared. So now we have some math to do. Let's see. So this is essentially x cubed over L squared. So because we have an x times an x squared. So when we take the integral of that, we're going to have x to the fourth, because we're going to add 1 to our exponent, and then divide by that exponent plus 1, and L squared is still there hanging out. We could kick them over to the other side, but it's going to come back together anyway, so I didn't want to. We're still going to evaluate that from 0 to L. Our 0, that's going to get canceled out. So we're essentially left with, when we plug in L for our x, we have L cubed over 4L squared. So 2 of those L cubed are going to get canceled out. So we have L squared over 4. But I'm not done. Okay, that was just my integral of x dm part. I'm going to need that, but I'm not done. So now m, our total mass, we don't know that. But you can essentially get the total mass by adding up our tiny pieces of mass, which is just taking the integral. So we're not, I know that looks weird, but we're going to just go through the same process just without this x here. So it's going to look really similar, but you're going to get a different answer. So again, I sub in lambda dx. Then I sub in lambda. So now I'm integrating x squared over L squared with respect to x. So now, since I don't have that x there, now I'm just down to x cubed over 3L squared. Now I'm going to evaluate that from 0 to L, plug in L for x, or if you actually know the length of the rod, you'd plug in the length of it as a number there. And we'll do an example of those. So 2 of those are going to cancel, so we have L over 3. Now, going back to our whole equation, this is what m is equal to. We need 1 over m. So we need to flip that around because m equals L over 3. 1 over m is going to be the inverse of that, which is 3 over L. So now we have our 2 parts to our equation. Now we just need to smush them together. So 1 over m, well, we just said that's 3 over L. Integral of x dm, well, we said that is L squared over 4. I can do that math. One of those L's cancels out. 3/4 L. So going up to our picture, it's like 3/4 of the way down, which makes sense. So if I were to just outline the steps we just took, we'll do that in purple because that sounds fun. Okay, the first thing we did was solve for integral x dm. And to do that, we need to sub in dm is lambda dx. Then we need to sub in lambda equals whatever. Then we just integrate and solve. Our limits for that integral are going to be 0, which is one end for our reference point, the length of the object, or L if you don't know it, and solve. Okay, but then we're not done. Then we needed to solve for m, which is integral just dm, and we take the same steps. So sub in dm equals lambda dx. We're going to sub in lambda equals whatever and integrate with our limits being 0 and L and solve. The last thing we did was smush them together. I will add, once we solve for m, then you're going to take the inverse to get 1 over m. That's where we want to end up. So now we plug in those answers. That we got in steps 1 and steps 2, and find the position of the center of mass. I think I have one more practice problem we can do. Okay, let's do one more practice problem with actual numbers. So here we're going to have some non-uniform thin rod, so another club blob. Now this one actually has a length of 30 centimeters, and its linear density is going to be, oh, it bugs me that I'm purple still. Okay, so its length is 30 centimeters. Its linear density is 50 plus 20x. All right, so if I were you, I would now pause the video and see if you can follow the steps by yourself, and then come back and see if you did it right. So welcome back. I'm glad you had such an easy time solving it. Good job. All right, I'm just going to write out. Okay, so integral x dm sub n lambda dx sub n or lambda, which is 50 plus 20x. So we have x times lambda So if I distribute that x, then I have 50x plus 20x squared. And I'm integrating that from 0 to 0.3. Okay, I'm going to go ahead and just put in my actual length there. So integral of 50x plus 20x squared. So that's going to be 50x squared over 2 plus 20x cubed over 3, which I'm going to evaluate from 0 to 0.3. So when I do all that math, so I have 50 times 0.3 squared divided by 2 plus 20 times 0.3 cubed over 3. All right, so for that part, I get 2.43 meters. But we're not done. Our total mass of this object, so that was step 1. This is step 2. Okay, so we're going to do integral of lambda dx. Then we're going to sub in lambda. So you can see it's all the same, just with one fewer x. Okay, so when I integrate that from 0 to 0.3, I get 50x plus 20, essentially 10x squared. Evaluated from 0 to 0.3. So then 50 times 0.3 plus 10 times 0.3 squared. When I plug in 0, that's all going to go away, so I don't need to do the other part of that limit. So I get a total mass of 15.9, which will be in kilograms. Now plug it into my overall equation. You can take the inverse, or you can just take the inverse here. So 1 over 15.9 times integral of x dm, which we said was 2.43. So that gives me a center mass of 0.153 meters. So a little bit off center, wherever that is. Okay, so it's a lot of calc, but follow the steps and you can do it. There's one more of these on the homework. You should be able to do all of the next learning target at this point, which I think is D. The last chunk is going to be system of many particles, which will be the next notes.